And now if we run make, see it, and yeah, as I said, it's really nice that it shows you the commands. Maybe the last thing we can see now is, obviously, if we run make again, it's all done. But if we go to ds.c and we add a comment just to make a small change, see it compiles just ds.o. It doesn't compile this main file anymore because we already have the object file. It doesn't need to do that. It just compiles the ds.o object file, but then it has to link all the object files again, which, I mean, it's one less thing to do, I guess, right? Alright, so back they completed at the gym, and now it's time for the mandatory daily coding session. And actually managed to pull this 60 kg baddie, and now it's time to pull the latest changes. Oh, actually forgot that I don't have a GitHub repo for this project, but you know, I guess I'll make one. This was the first project in C project, but yeah, I forgot I didn't make a GitHub page for it. So what's the plan for today, right? If you remember last time, we just made a clone of the cat program, and there was one comment which I can answer now in the beginning. It was, why don't we just paste, like once we read a file, why do we also allocate a buffer for the entire content, right? Why do we do this append here? And I guess, you know, you could just print the contents directly, but my idea was to just showcase, you know, using malloc and in the end reaching to this string builder data structure. I mean, you know, you don't need it, but just in case you encounter you know, a problem where you need to use something like this, then you already know how to use it because you saw it here, right? So that was the idea. And last time, you know, we were compiling the program by using clang, like just the command. And I saw another comment which asked, well, how do we use make, right? Because it's a useful tool when your project grows. I'd say if you have only one file, you should keep it simple and just go with using GCC or clang on your file. But you know, with make you can, because you can forget some flags, you can forget to use some specific flags. Like for instance, I usually also like to use WAll to show all the warnings. In this case we didn't have any, but imagine we had some warnings. Or maybe even using the W error flag, right? To, or is it with 2 dashes? I think it should be, no, it's with only one, yeah. So yeah, you know, you have some of these flags which maybe you forget about them. Like you saw, I was like, wait, is it with 1 dash or multiple dashes? But if you have a makefile, you just write these commands in the makefile itself, so you don't have to worry about them. And I was thinking to go over the makefile structure. How do you write a makefile in this part, and then we'll try to implement a makefile from scratch and understand how it works, because maybe it's a bit confusing to just say, oh, how does the makefile, like how does the incremental compilation work? That's the more interesting aspect of the makefile, because just having a single command in there, it's straightforward how it works. But once your project grows, it becomes a bit more complex, and maybe you don't want to compile everything from scratch every time. Maybe you just made this really small change in one C file, you compile just that file, and then you know, you don't have to wait for all the C files to compile again. So that's why a makefile would be good. But on the other hand, you can do the same thing even without a makefile. So you know, it's just for convenience. So let's try to write our first makefile for this first project, you know. So what am I gonna do here is just have and I guess how makefiles work, they have a list of targets. Here, for instance, main is a target, and usually targets are files that you want to generate. So here we want to generate a file called main, but you'll see in a second that that's not always the case. You can have targets that you use more or less as bash scripts, but in this case we create a target for our main file, and then it follows like a column, and then you have a list of files that are required to generate this main file. And the idea here with the requirements, it's more about, let's say, if a file changes, then this target will be triggered, right? So if the main.c file changes, or ds.h, because we have the ds.h here, if any of those two files change, then we have to run this target, like the following command again, and the command is going to be just this, right? And obviously I'll go over stuff like because there are things like this, I guess, right, which is the convenience, like really short macro to not have to write the name again. It refers to this thing. There are more of them, but I think this one is the more interesting one. So if I run just make main, which is the name of the target, it's gonna say, well, our main file is up to date. And I guess the interesting point is, how does make know when this thing is already up to date and we don't have to do anything? Because if we run clang, it compiles it, like it runs the command. Well, if we do ls-lah to see it in human readable format, we see that the time when this main file was created is 12:50, and the time when this file was changed is like 1 week ago. So based on this timestamp, it knows that, well, our executable is newer than the dependencies, because both of them are like 1 week old, and it knows that, well, the main file clearly is already up to date. But what happens if we go to the main.c file and small change, we add a comment. Now if we run ls-lah, we see that this main.c file is newer than the executable, and if we run make main, it's gonna run the command, right? And now the executable is newer. So that's how make knows when to build something, right? So, but this is extremely simple. Like, if you only need stuff like this, and pretty easy. Usually I like to define stuff like cc and then use it like this. I noticed this in a lot of make files, that they have this kind of pattern, and maybe even C flags, or I guess it's compile flags or something like that. And I just put all of them here. Don't remember exactly though. C flags or something like this, right? And obviously if we run make main, you see, and here I really like that it shows you the command that it generates. I think that's a really good thing to see. So that's how I usually like to write these things, because I can just imagine if I had a lot of targets and I just reuse this thing everywhere, because if I change it in some place, maybe I want to show it everywhere, like to use it everywhere. I think W extra is another one. Let's see if we, okay, whatever. I'm pretty sure make has some kind of force. I mean, I know the dash k is like keep going even if it fails. that's sometimes useful. Because like if one rule fails, like if one target fails, then it just tries to build as much as it can. But I don't remember. I'm pretty sure I saw at some point there was something like force, but I don't think it's no. Okay. I wanted to force it to run this thing, but I don't remember how to do that. But anyway, this is the basics, right? And I said that there are some targets which you don't need to generate a file for, and usually that's the clean target, which we want to remove. Oh, rm. We want to remove the build. So if we run make clean, it's gonna remove the main file, and if we run make main, well, yeah, here it's the W extra, which I wanted to see. So a small compile error, let's try to fix it. So it's line 45. I guess it's something like this count is an unsigned integer, and here we defined I as a int, and it doesn't like that. So make main, and it runs that. And another cool feature of make, I think if you don't specify any rule, it's gonna run the first one that it finds in the Makefile. And usually I like to have a rule like build, which is just gonna depend on main, right? And if I run make, it's gonna do build. And the interesting thing about these two targets is that they don't have a file that is generated, right? So let's say make clean, and let's touch a file called build, and I do make build. You know, I was expecting to see something like this message right away, because we have this build file which is already existing. Let's make a change in the main file. Let's add another comment, and now if I do make build, interesting. You know, always had this issue that if you don't specify something like phony build clean, and phony means that there's no file being generated, or if we have a file, you ignore it and you always run these rules. But yeah, I don't know why it worked first try. But if I do make build, see, and now, yeah, strange. I mean, if it happens to you that you have rules that you don't generate files for instance build or clean, it's a good idea to put this thing with .phony, which just means that these are not gonna be files, these targets. They are just there for convenience. Right, so that's the idea here. And I was thinking maybe for the Nix file, because, but this is like a bit unrelated. I have just the dev shell. Yeah, let's not look into this one for now. It's something like for NixOS, if you have a Makefile with a build rule and an install rule, you can just specify something like this thing here, and then you can run nix build, and it knows that the Makefile needs to be used. But that's, you know, specific to Nix, so it doesn't matter. So yeah, that's the idea here. And now let's say we want to do something like incremental, like compile things incrementally, because that's why Makefile is really useful. So let's make a ds.c file. I usually, when I use ds.h in a bigger project, I like to have a ds.c where I define all of these things. I'd say this is the best way to to use ds.h in a bigger project, you have a ds.c where you put, basically, if you think about it, if you do it like this, it's just like copy pasting. Interesting. It's just like copy pasting the implementation from this file. I just need to get to the implementation, but you get the idea. It's like taking this whole implementation and pasting it in this file, right? That's what these defines do with ds.h here. So that's the idea. And then we don't need to define these things anymore in the C file. So let's see what happens if we just run make. Well, it's gonna shit the bed because we no longer have the definition or like the implementation of the functions. We only have the definition of them. So it knows that these functions should exist, but it doesn't know like how to use the code because we haven't included ds.c in the Makefile. And I think you could just put it like this. I'm not 100% sure, but I think, okay, whatever. I guess I defined false multiple times, but I guess it's an issue with because it's using Clang, and I think Clang already has all of these things, but I'm not sure. Whatever, doesn't matter. So let's just pretend that this thing would work, right? And what would happen here is if we make modification in ds.c or in main.c, this would need to compile both of the files every time, right? And we don't really want that. We just want to compile the one that's actually changed, right? So what I'm gonna do here is create a few more rules. For instance, ds.o is gonna create an o file, and this one is ds.c and ds.h, right? I'm not gonna go into the patterns and wildcards because, to be honest, I think sometimes those are useful, but in most cases it's gonna be annoying because of the header files mostly. The header files are pretty difficult to do with that pattern, and I'll show you why, but we don't have that many header files anyway. So let's just cc c flags, the compile flags, and ds.c, and we want to create ds.o, which is just I'm not sure if I need to specify -c, but I'm just gonna do that. All right, and let's also have main.o, which depends on main.c, and ds.h. And I guess a good rule of thumb to know which header files to use in the target is to just look at your include list. And if you see one file, it means that it needs to be included there. Because if ds.h changes, then you need to recompile main. And the same is true for this one. It includes ds.h, you need to have it in the rule. And I know there are some build tools which automatically generate rules like this for you, but we are just trying to do it manually because it's more fun, or I guess a good way to understand how stuff works. Okay, so we have both of these rules, right? And I guess the last step is to just make the main file, which is going to depend on ds.o and main.o, and we want to basically just ld these two files, I guess. So if we run make, oh shit. Okay, whatever. I just replaced that with cc again and it was fine, but I'm not sure why it complains about true and false. Uh, weird. I mean, it's inside of the if not defined, so it shouldn't have that problem. Maybe I defined it in the main file or something. No, whatever. Now I'm curious why if it would work better with GCC, or no, it still doesn't like that. No, I'm just gonna go to the ds.h file and let's just do these things with define, because why not? Right. Oh, without the semicolon. So it's fine, alright. So if we run the main file, okay, so if we just run it on ds.c multiple times, you see it concatenates the file as we expected. So we made a really small refactoring, but it was mainly for showcasing the how to build this, how to write this Makefile, right? So yeah, that's the idea. And sure, you could use the wildcards, but to automatically generate your .o files, but I think maybe it's better in the beginning to just use this stuff, and we can go in a more depth scenario with more makefiles. But I think it's a good start for now to just focus on your makefiles and build them like this. Even if you have to write more, I think it's fine. Maybe one more thing here is an interesting one. If you use the, I think it's this variable. Wait, let me just make clean. Well, I guess now we have to update our clean to also, don't make the mistake to put, yeah, also the ds.o, like the object files as well. And now it compiles everything from the beginning, you see. And I think this one is, this macro here means all of these files. And I think there is also this one, which just takes the first one. We can use this one here. Pretty sure that's what it does, if I'm not mistaken. So let's make clean, and now if we run make, see it, and yeah, as I said, it's really nice that it shows you the commands. And maybe the last thing we can see now is, obviously if we run make again, it's all done. But if we go to ds.c and we add a comment just to make a small change, see it compiles just ds.o. It doesn't compile this main file anymore because we already have the object file. It doesn't need to do that. It just compiles the ds.o object file, but then it has to link all the object files again, which, I mean, one less thing to do, I guess, right? So yeah, hopefully this is a bit useful to understand Makefiles. And yeah, in the next part we'll try to build Makefile from scratch. I'm not sure if it's it's gonna be only one part or multiple parts, but that's what I'm thinking we can do together and try to, because it's gonna have some steps, like for instance, we'll have to be able to parse something like similar to this, but I was thinking to make it simpler in the idea of you can just define rules. You don't have variables or macros, you just have rules like how this one looks like, right? And this is gonna be the target, then a list of files that we need to check, which, as you can see here, can be other targets or just files. And yeah, we'll basically have to check if this file exists, and if it's older than the targets, then we have to run the command and stuff like that, which I think should be pretty interesting to do. So yeah, hopefully this was useful and was a short introduction on Makefiles, and we'll see in the next one. So see you.